Welcome to the elementary synthetic geometry-based introduction into inversion of the real plane with respect to a circle course, episode 1, lecture 1, in which we will cover the goals, the prerequisites, and the roadmap, and thus the overall structure of this course. This course has at least two foreground or primary goals and at least two background or secondary goals. The first primary goal of this course is to evidently introduce our viewers into the technical essence of inversion of the real plane with respect to a circle by the means of synthetic geometry only, and with the minimal amount of pre-existing mathematical knowledge. The fact that we will be studying inversion of the real plane with respect to a circle by the means of synthetic geometry means that we will not be relying on the apparatus of the so-called analytic geometry. There will be virtually no symbolic shuffling in this course, and we will be operating solely in the terms of the so-called Euclidean tools alone, or in terms of only a straight edge and a compass. The fact that we will be studying inversion of the real plane with respect to a circle using the minimal amount of pre-existing mathematical knowledge also means that we will introduce one possible definition of that geometric transformation in the most basic or the most elementary way possible without, it is important to understand right off the bat, without the reliance on the notion of the so-called polar of a point with respect to a quadratic curve. I will say a few words about a possible definition of inversive geometry using exactly the notion of the polar of a point with respect to a quadratic curve at the end of this course in the episode 29. Now, because of that, on the one hand, we will not be doing any symbolic shuffling whatsoever in this course. That's on the one hand. But on the other hand, we will be doing mathematics. And that brings us to the second primary goal of this course, which is with the content and the structure of this course, we want to show our viewers that at its most fundamental level, first and foremost, mathematics is an art form. In other words, with this course, we want to show our viewers that mathematics is an art. Mathematics is an art of telling a story. Mathematics is an art of telling a story of how and why. Mathematics is an art of telling a story of how and why, wrapped into the technical language of if P then Q implications, not and or logical connectives, the universal for all or for each, and the existential there exists quantifiers. From the first two primary goals of this course, there naturally follows the first secondary goal of this course, which is, with the material presented in this course, we want also to showcase the fact that mathematics is a process. A process of what? Mathematics is a process of precisely telling a story. And with this presentation, we would like to showcase the fact that no single mathematical result grows on a tree all by itself or pops out of nowhere into this world in its final instance. We have to fight for each and every mathematical result, and that fight unfolds tactically precisely as a process. And the second secondary goal of this course is to show how the layer or a specific layer of mathematics becomes the specific layer of mathematics and is developed, precisely because mathematics is an art of telling a story, and the act of telling many such stories becomes a process. And how does this process manifest itself? Well, this process manifests itself in a technical and tactical immediate level as a hierarchy of certain theorems. Thus, the second secondary goal of this course is to show precisely how this hierarchy of theorems can be put together, and the corpus of such theorems becomes the layer of mathematics, and how that knowledge becomes the textbook knowledge. The prerequisites for taking this course are very, very low and are very, very modest. First of all, officially, as this platform requires, there is absolutely no age restriction for taking this course, and literally any person between 1 and 151 years of age can take this course, because just about the only two things that you should possess prior to stepping into the material that we will present in this course are the following two: the basic situational awareness, or in plain English, the street smarts. If you possess the basic cognitive skills of taking some amount of very basic, very elementary mathematical material that we will mix into our definitions and then shuffling them around in order to submit them to your will to accomplish the task that we will put in front of you, then you are good and you are in. And the second prerequisite for taking this course is the basic and quite modest knowledge of the basic plain Euclidean geometry at the level that is not higher than the average upper middle or lower high school by US standards. Above all, these official prerequisites aside, the personal traits that will ultimately determine the level of your success in gauging the material that we present in this course is the genuine desire to learn something new and the willingness to step out of your comfort zone. Which brings us to the third and the last item of lecture one, which is the structure of this course and what will you learn by the time you finish taking this course. I have structured this course in a college-like fashion, which means that if you are in middle or high school, then by working through the material that we present in this course, you will be able to form a realistic expectation and a realistic idea of how things work in college. And if you are in college now, or if you are out of college, then you are already familiar with the format of college-like presentation. That is, in this course, we will prove 44 theorems. We will solve 29 problems, which are smudged across 29 episodes in total. And these episodes are partitioned in the following way. The entire course is broken up into three big chunks: theory, problem solving based on the theory presented and the theory studied, and the practical applications that combine everything: your problem solving abilities and your knowledge of theory. And this partition is done as follows. For the theoretical part, we will have 9 lectures spread across 9 episodes. In other words, the first 9 episodes will cover 9 lectures that comprise the theoretical material of this course. Within these 9 lectures, we will solve, if memory serves me right, about 9 problems, but these problems are of a low caliber and they are designed to test your understanding of the material at the immediate and tactical level. And these problems are not very difficult at all. They're just introductory problems to make sure that you follow the theoretical material. Once we're done with the basic theory that we will cover in this course, we will move on to the process of solving problems. And I will say a few words about this dynamic duo in a few seconds. In the problem solving section, we will have 9 seminars spread across 9 episodes. In other words, the next 9 episodes will cover 9 seminars. And the way I structured each seminar is as follows. One seminar covers only one problem, and it is painfully and immediately obvious what material, what theoretical apparatus should be used in order to solve that problem. The geometric transformation of inversion of the real plane with respect to a circle. And in the very first seminar, I will present the overall approach of how the mechanics of inversion of the real plane with respect to its circle can be spliced into the process of searching for a solution of the problem. So here we will solve 9 problems across 9 seminars in the 1 problem per seminar, 1 seminar per problem fashion. Once we're done weaving the problem solving skills into the knowledge of the theoretical material, and conversely, the knowledge of the theoretical material into the process of solving problems, we will move on to the third and the final big chunk of this course, which is the practical application of everything that we have learned during the previous 2 big chunks. This practical application section will consist of 10 practices spread across 10 episodes. Again, the following 10 episodes will consist of 10 practical sessions. And in each such practical session, we will also solve 1 problem per practice and 1 practice per problem. But the tactical flavor of the problems that we will be solving in this practical application section of this course do not necessarily tell you and are not necessarily suggestive that yes, go grab inversion of the real plane with respect to a circle, plop it on top of this problem, and voila, problem solved. So the problems that we will solve in the practical section of this course will be slightly removed from the material that we will study in the previous 2 big chunks, but there is a connection between the 2, and we will precisely apply what we have learned in these 2 big chunks when we will be working with the material presented in the 3rd big chunk of this course. And evidently 9 plus 9 is 18, 18 plus 10 is 28, the number of episodes is 29, and the final episode will be the epilogue and the farewell, in which we will look at where we can go from that point forward and in which direction we can take the further study of inversive geometry. Now, in a few seconds, I will go over the details for each big chunk of this course, and do not worry if you miss something while watching my presentation. You can always catch up with the printed material. I have a free PDF course syllabus available in my free GitHub repository. The link is in the comment section. Be my guest, download the PDF file, and keep it front and center. In the first 9 episodes of this course, we cover the following material. In episode 1, lecture 1, we cover the goals, the prerequisites, the roadmap of this course, and the overall structure of this course with the remarks that I'm about to make. In episode 2, lecture 2, we cover the motivation, the relevant definitions, and we agree on the terminology that we will use in this course. In episode 3, lecture 3, we will see how inversion of the real plane with respect to a circle acts on points. This will be part 1 of 2-part installment in which we will cover the theorems 1 through 5, and we will solve the introductory, straight edge, and compass problems 1 through 5. In episode 4, lecture 4, we will keep studying how inversion of the real plane with respect to a circle acts on points, and that will be the part number 2 of the 2-part installment. And in that lecture, we will prove the theorems numbered 6 through 8, 6, 7, 8, and we will also solve the relevant problems numbered 6 through 9. Once we understand how inversion of the real plane with respect to a circle acts on points, we will move on further, and in episode 5, lecture 5, we will see how inversion of the real plane with respect to a circle acts on straight lines. In this lecture, lecture 5, we will cover theorems 9 through 14. There will be no problems, but if you can find some interesting problems to solve, then by all means be my guest. In episode 6, lecture 6, we will start looking at how inversion of the real plane with respect to a circle acts on circles. That lecture will be the part number 1 of the 2-part installment, and in that lecture we'll prove theorems 15 through 23. In episode 7, lecture 7, we will keep studying how inversion of the real plane with respect to a circle acts on circles, and that will be the part number 2 of the 2-part installment. In that lecture, we will prove theorems 24 through 31. Next, we will look at how inversion of the real plane with respect to a circle acts on angles. Specifically, we will deal with magnitudes, remember, because it is always possible to attach 2 attributes to an angle, the magnitude and direction. In this course, we will mostly not deal with directions, even though we'll say a few words. We will mostly concentrate on magnitudes of angles. As such, in episode 8, lecture 8, we will study how inversion of the real plane with respect to a circle acts on magnitudes of angles, and by doing so, we will prove theorems 32 and 36. In the final lecture that will conclude the study of the theoretical material in this course, in episode 9, lecture 9, we will look at how inversion in the real plane with respect to a circle acts on tangency between circles and straight lines. Then we will introduce the notion of the power of a point with respect to a circle, and we will study at the very basic level the notion of radical axis of 2 circles. We will prove the theorems 37 through 44, and we will solve the single problem in that lecture, problem number 10. The next 9 episodes, the episodes number 10 through 18, will cover the 9 seminars of our course, which will be numbered 1 through 9, and they will go as follows. In episode 10, seminar 1, we will cover the basic approach of how problems in mathematics can be solved with the help of this wonderful geometric transformation known as inversion of the real plane with respect to a circle, and we will look at the sample problem number 11 that will deal with a very straightforward situation of tangent circles. This problem will be very not complicated at all, because again, this is my style and this is who we are and this is what we do on this channel. When we explain a new concept, then we use a very straightforward material to understand how that concept works, because once we understand how this or that mechanism or concept in mathematics works, we can crank up the perceived complexity of the material onto which we unleash this concept without any upper bound, so to speak. Next, in episode 11, seminar 2, we will still be dealing with tangent circles. We will solve the problem number 12, and that problem will deal with 2 circles and 1 point. In episode 12, seminar 3, we will still be dealing with tangent circles. We will solve the problem number 13, and that problem will deal with intersecting circles. And we will conclude the dedicated and short study of tangent circles in episode 13, seminar number 4. We will solve the problem number 14 in that seminar, and this will be actually quite famous and very interesting for us, the so-called the Apollonius three-circle problem, and we will see how basically this wonderful geometric transformation, to which we refer as inversion of the real plane with respect to a circle, basically eats this otherwise quite challenging problem for breakfast. In episode 14, seminar 5, we will take on the study of the so-called orthogonal circles. We will solve the problem 15 in that episode, and that problem will deal with 1 circle and 2 points. So for your reference, when I say something plus something, means that the combination of these mathematical objects provides a certain constraint within that problem. In episode 15, seminar 6, we will study the orthogonal circles further. We will solve the problem 16 in that seminar, but that problem will deal with 2 circles and 1 point. Next, in episode 16, seminar 7, we will still study the orthogonal circles, and in that seminar we will solve the problem number 17, and this problem will deal with the way in which it is possible to take pretty much any 2 circles and invert them into concentric circles or circles that have one and the same shared center. In episode 17, seminar 8, we will start solving mixed problems, and in that seminar we will solve the problem number 18. This problem is also quite famous. It is known as chain of Pappus, and this problem is also absolutely amazing when we try to solve this problem without inversion of the real plane with respect to a circle. Then it becomes very challenging, but the very notion or the operation of inverting the real plane with respect to a cleverly chosen circle basically eats this problem for breakfast, and the following computations that ensue become pretty much baby sub-middle school computations. We will see the miracle of inversive geometry weaving its magic on this problem. And finally, in episode 18, seminar 9, we will be dealing with mixed problems. We will solve the problem number 19 in this episode, and I titled this problem an Arbelos encounter. This will also be an interesting problem. Here we will see a very natural setting when inversion of the real plane with respect to a circle in negative power comes in quite handy. In the next episode, we will learn that inversion of the plane with respect to a circle comes basically in 2 flavors, with positive power and with negative power. Most of the time, we will be dealing with the inversion with positive power, but in this problem, the problem number 19, we will see a quite natural setting that lends itself for the application of inversion of the plane with negative power. And before we move on to the description of the practical application of what we have learned, I would like to say a few words for those of our viewers who are not the regular visitors to our channel. The process of solving problems that I outlined over here is very closely connected to the process of studying the theoretical material, and I explain this connection and the symbiotic relationship between the two on the Problema channel in season 1, episode 1. Here I give the several faithful enough definitions of mathematics, I highly recommend that you don't have to, but for a smoother experience with this course, I highly recommend that you guys find the season 1 episode 1 on our channel. Again, the link will be in the comment section, and watch this episode in its entirety. Think about what we say in season 1 episode 1, and then watch season 1 episode 2, because here in season 1 episode 2 we explain how to practice mathematics correctly. In other words, we explain a way, not the way, but a way following which you will derive the most academic benefit for yourself from trying to solve this problem. Because yes, we will present and discuss the solutions of all these problems in great detail in a public setting, but in season 1 episode 2 you will see that our suggestion is that first and foremost you try to solve all these problems on your own, and it's okay if you cannot, if you fail, as long as you have nicely documented paper trail of what have you tried, why have you failed, and where have you failed, and you do carry out the next steps correctly. Instead of watching our presentation in its entirety, only watch the minimum viable amount of information. At the point where you say, oh, okay, I see where it's going, at this point we recommend that you walk away from our presentation, put this video on pause, and go try to finish the solution of this problem and carry it home all the way on your own. As such, we recommend, as unofficial prerequisite for a smoother experience with the material that we present in this course, find the season 1 episode 1, season 1 episode 2 on the Problema channel. The links are in the comment section. Watch both of these episodes several times. It's okay to watch each of these episodes 2, 3, 4, 5, 17 times. It doesn't matter, as long as it helps. You should really watch it, and you can watch these episodes in parallel and then bring your ideas, bring your thoughts to the material that we present in this course, and specifically to the process of solving problems in this course. And again, do not worry if you miss these two guys. I will be mentioning them at the beginning of each seminar. The next 10 episodes, numbered 19 through 28, will cover 10 practice sessions, or just practices, as we say here in US, that will be numbered practice 1 through practice 10. And within these practices, we will take our knowledge of the basic theory and the basic problem solving skills further by taking on some interesting problems that, as I mentioned before, slightly removed from the immediate neighborhood of this specific geometric transformation to which we dedicated this course, and to which we refer as inversion of the real plane with respect to a circle. That is, in episode 19, practice 1, we will solve the problem number 20 that will deal with 4 pairwise externally tangent circles. The challenge in this problem will be to show that the points of tangency form a quadrilateral that is cyclic. Again, up front, it is not entirely obvious that inversion of the real plane with respect to a circle can be used for the process of generating a proof. Meanwhile, that is precisely the case, and that is why we will take on this problem as the first one. Next, in episode 20, practice 2, we will solve the problem number 21. And in this problem, we will see that inversion will meet a so-called recurrence relation. If you do not know what a recurrence relation is, do not worry. At the beginning of this practice, I will explain what it is. It is not that complicated. In episode 21, practice 3, we will solve the problem number 22. And in that problem, we will see that inversion will be hashed with or mixed with an alternative reasoning. And the reason I bring this problem into the mix, because back in my time, when I was in college, all the exams for theoretical physics majors were held in a strictly verbal real-time face-to-face format. And one of the popular questions that professors used to ask us is, okay, this is fine. This proof that you just presented is correct, but please give us a different proof or pivot to a different direction. Give us an alternative reasoning. And we will practice this with this specific problem. In episode 22, practice 4, we will solve the problem number 23. And this problem will also deal with inversion that can be used in the context of verbal college entrance exams. Back in my day, for example, I sat through written and verbal physics and mathematics exams for the entrance into the college which I attended, and we will cover this specific scenario in this problem. Next, in episode 23, practice 5, we will solve the problem number 24, and we will see how the new theoretic tool that we will learn, inversion of the real plane with respect to a circle, can be used in order to generate new proofs of existing theorems. In other words, we will take a particular theorem from plain Euclidean geometry, and instead of traditional proof, we will generate a proof of that theorem based precisely on the notion or on the transformation of inversion of the real plane with respect to a circle. In the episode 24, practice number 6, we will solve the problem number 25, and in this practice we will address a very popular question. Young students are always eager to know why are we studying this, and where in real life can this be possibly used? Well, here in this practice session, we will see how inversion can be applied in real life, and we will study the basic mechanics of the so-called Pousselier-Lipkin linkage. And this gentleman over here, Pousselier, I think, if I'm not wrong, he was an officer in the French army. Meanwhile, it does not prevent him from exercising his intellectual abilities and putting them to a good use. In episode 25, practice number 7, we will solve the problem number 26, where we will take on a problem that has a distinct Japanese flavor. These types of problems are known as sangaku, and I titled this episode From Japan with Love. We will see what is the result of the collision between the inversion of the real plane with respect to a circle and a sangaku problem, and the result is very good. We will solve this problem. In episode 26, practice 8, we will solve the problem number 27, where we will look at another beautiful, elegant, crisp problem when a circle, a smaller circle, is rolled into a circular segment. A particular statement can be made. It can be framed as a problem or as a theorem. Pick your favorite. In episode 27, practice 9, we will solve the problem number 28. And in this problem, we will deal with the demand or the request to intersect a given circle under a given angle. Basically, this extra material that makes these mathematical problems interesting comes with certain constraints. Lastly, in episode 28, practice 10, we will solve the problem number 29. That will be the problem that will conclude our initial study, and I gave that problem and that episode a romantic name, T for 2 and 2 for T. We will see what that is all about when we get over here. But again, when we will be solving this problem, I recommend that you guys find season 1 episode 1 and season 1 episode 2 on the Problema channel. Watch these episodes as many times as needed to reconcile all the ideas that we present in these episodes in your mind and practice mathematics correctly. The final episode of this course will be the episode number 29. I have named that episode Epilogue and Farewell. And in that episode, I will provides several suggestions for where the knowledge that you gained during that course can be taken further. For example, it is possible to take what we have learned in this course and look at the foundations or at the beginning of the so-called theory of pencils of circles, abbreviated to POC, and the information that we learn about what happens, for example, to orthogonal circles under the inversion of the plane with respect to a certain circles can be taken precisely into the theory of pencils of circles. And for those who do not know what a pencil of circle is, basically this is another word for many circles looked at as a certain whole. That is one direction in which the knowledge of the basic inversive geometry of the real plane can be taken. Another direction in which that knowledge can be taken is the same idea, inversion of the plane, but this time not of the real plane, but of the complex plane, the set of complex numbers designated with the uppercase C. That is why you will see in the thumbnails and the opening screens for all the episodes on this course, in the upper left corner of your screen, there will be the so-called chain of Pappus, and inside the chain of Pappus there will be the letter R, because letter R will designate the inversion in the real plane. And before moving any further, let us agree that the abbreviation IGRP for the duration of this course, for the entirety of this course, stands precisely for I for inversion, G for geometry, R stands for real, P for plane, IGRP, inversive geometry of the real plane. And once the mechanics of the inversion of the real plane are understood, that idea can be taken further into the complex plane. And in many texts on complex analysis, you will see that this particular geometric transformation, inversion of the plane, is mentioned, but mentioned only on a tangent. Pretty much none of the textbooks that I looked at go into any reasonable depth beyond the simple algebraic definition of what this geometric transformation is. So knowing as much as possible about this transformation in the complex plane is beneficial by all means. Another direction in which the knowledge of the basic ideas of inversion of the plane can be taken is the inversion of the three space, not the plane, but the three space. And this time inversion is done with respect to a sphere. And once that idea is consumed, it is also possible to take it, this idea, further, or the idea of inverting the space not only in the sphere, but in the other more elaborate surfaces, let's say. And these surfaces have to do something with this yet another direction in which the basic knowledge of inversion of the real plane can be taken, and that is more unitive in some sense, and by the same time more broad or broader view at the notion of inversion of the plane, and that is the notion of inversion of the plane in conic sections. That is, inversion of the plane in a hyperbola, the inversion of the plane in an ellipse, and the inversion of a plane in a parabola. And this is where the ideas that I talked about earlier, the so-called polar, the notion of a polar, of a point with respect to a quadratic curve, comes in. And through this notion of polar, that is how the idea of inverting the plane in the popular conic sections is introduced, where the product of two distances even is equal to a square of a certain other distance. And that is how the basic knowledge of how inversion of the real plane in a circle works can be taken further. And coming back a little bit to the idea of inversion of the three space in a sphere, with these guys can be combined in which way? Well, once we begin rotating these guys around certain cleverly positioned axis, then we get what? We get the so-called either solids or surfaces of revolution. So, for example, inversion of three space in two-sheeted, let's say, if you know what is two-sheeted hyperboloid is two-sheeted hyperboloid. This is basically a surface that looks like this. It's one cup that sits on top and another cup that sits like this at the bottom. Then it is entirely possible to define in a meaningful way the inversion of three space in such a curious looking surface in a two-sheeted hyperboloid. If you know what a one-sheeted or what a hyperboloid in one sheet is, then it is possible to define the inversion of three space in one-sheeted hyperboloid. It is possible to define the inversion of the three space in an ellipsoid or a surface that looks as follows: this way, and for example, let's say this way. It is entirely possible to define the inversion of the space in a meaningful way, not in a sphere, but in a square sphere. And before we move on, I would like to say that this course is based on my much more voluminous and much larger book that is called Inversive Geometry for All. This book is completely free. All the PDF files are free that are available in my free GitHub repository. And what that means is that every episode that I present for this course has an accompanying PDF file that is basically a chapter from my free Inversive Geometry for All book. So if you think that watching the material that I present in the visual format is not enough, I will be providing a link to a free PDF file, which is basically a chapter from my free PDF book that is available free of charge from a free GitHub repository. For each and every episode, be my guest. And now this is it for episode 1, lecture 1, and I will see you in the next episode, episode 2, lecture 2, in which we will motivate the introduction of the geometric transformation of interest, inversion of the real plane in a circle. We will give several relevant definitions that come along with that transformation, and we establish a common terminology.